here is question number 11. A faulty thermometer has ice point at minus of 5 degrees centigrade and steam point at 105 degrees centigrade. What should be the temperature shown by this thermometer of a person? It is assumed in the question that the correct temperature of person is 37 degrees centigrade. Now, student, we know a very famous relation in thermometry, that the current temperature minus of lower fixed point of any thermometer divided by upper fixed point minus of lower fixed point. This particular expression is always constant whatever thermometer you are using, whatever scale you are using. This expression will always be constant. So this expression will be same for faulty thermometer. This expression will be same for correct thermometer also. Suppose the correct temperature of thermometer or the correct temperature is C minus. The lower fixed point for true thermometer is always 0. The upper fixed point for true thermometer in Celsius scale is 100 minus of 0. That is lower fixed point, which is equal to, let us write the same expression or above expression for faulty thermometer. Suppose the present temperature given by faulty thermometer is X minus lower fixed point is minus 5 degrees centigrade divided by upper fixed point is 105 minus of lower fixed point is minus 5. After solving, we will get C, that is 37 degrees centigrade divided by 100 equals X plus 5 whole divided by 110. Now if we solve for X, we will find that X equals 35.7 degrees centigrade. So this is our expression, final answer, and if we search the option, we will find that third option is absolutely matching. So it is correct. Now let us proceed to the question number 12. Now here is the question number 12. A particle is executing SHM, simple harmonic motion, if V1 and V2 are the velocities of the particle at distances x1 and x2 from the mean position respectively, then the time period of oscillation is. We know that the speed of particle is related to the distance from the mean position by the equation as V equals omega under root a square minus x square, where a is the amplitude and x is the displacement from mean position. So we can write for the V1, V1 can be written as V1 square equals omega square a square minus x1 square. On the other hand, the same way V2 square can be written as omega square a square minus x2 square. Subtracting V2 square from V1 square, we will get V1 square minus V2 square equals omega square x2 square minus of x1 square, because omega square a square will be cancelled out. Now from here we have got the omega as under root V1 square minus V2 square whole divided by x2 square minus of x1 square. As a result, the time period t, we will get 2 pi by omega, that is 2 pi by or 2 pi under root x2 square minus of x1 square whole divided by V1 square minus of V2 square. It means option 2 is the correct answer. Now let us proceed to question number 13. Third overtone of closed organ pipe is in unison with the fourth harmonic of an open organ pipe. The ratio of the length of the pipe is. Now, as it is given in the question, unison. Unison means same tone, same frequency. We know very well for an open organ pipe, fourth harmonic frequency will be given as F open. that is 4 times V upon 2 times LO, where LO is the length of open argon pipe. On the other hand, for a closed argon pipe, third overtone will be seventh harmonic, as we know from the relation Fn for open is given by 2n plus 1 multiplied by V divided by 4 times length of the closed argon pipe, where n equals to 3. So third overtone will be seventh harmonic. Therefore, frequency for closed argon pipe will be given by 7 times V divided by 4 times length of closed argon pipe. According to question, it is given that the situation is unison. Unison means F open equals F closed. Therefore, we will get the length ratio, length for closed argon pipe upon length for open argon pipe as 7:8. So we will go with option number 1. Now let us proceed to the question number 14. A person P is standing at a perpendicular distance of 100 meters from point Q on a highway. A bus capital B is moving with a speed of 30 under root 2 meter per second towards point Q on the highway, as shown in figure. The driver of the bus blows a horn of frequency 1200 Hz. The frequency of the sound received by the person P when the bus emits sound when it is at a distance 100 meters from the Q will be what? Student, whenever there is a relative motion between source and observer, then the frequency of sound received by the observer is different from the actual frequency of the sound produced by the source, and it is given by the expression frequency V dash, that is observed frequency, is equal to speed of sound in the medium. Here the medium is air, divided by speed of sound in the medium minus of speed of the source, whole multiplied by actual frequency of the source. Now bus has speed 30 under root 2 meter per second straight. Now the component of speed toward the observer will be 30 under root 2 cos of 45 degree, which gives you 30 meter per second. Now putting the values, we will get speed of sound in air is given 330 meter per second divided by 330 minus of 30 multiplied by actual frequency, that is 1200 Hz. So when you solve, you will get the answer, that is 1320 Hz. It means option number 2 is correct. We have to go with option number 2. Now let us proceed to the next question, that is question number 15. A metal rod has length capital L, radius of its cross section small r, Young's modulus y, and the thermal coefficient of linear expansion is alpha. It is clamped between two rigid supports with negligible tension. If its temperature is increased by T degrees centigrade, then the force exerted by the rod on any of the support will be what? We know that if we increase the temperature, then there will be a linear expansion in the rod, which is given by delta L is equal to actual length multiplied by the coefficient of thermal or linear expansion multiplied by rise in temperature. So from here we got change in length upon actual length, which is also known as strain, that is equal to alpha times T. Now we know that Young's modulus is given by stress divided by strain. We can write it further. Stress is F by area, and if we put the value of strain, that is delta L upon L, change in length upon actual length, we will get FL upon delta L. From here we got the value of force, exerting force, that is Young's modulus A delta L divided by L. Delta L by L is already we have calculated, that is alpha T. So the value will be Young's modulus multiplied by area will be pi r square multiplied by alpha times t. So this is the final expression. Now we will go with option number 4 because the expression final is matching with option number 4. Now let us proceed for the next question.